sites all across Northern Europe.
Yeah.
Behind every product stands a dedicated team of technical experts and experienced engineers ready to support you, with everything from everyday challenges to advanced connection solutions. When you choose Essve, you don't just get a product, you gain an experienced team ready to make a difference. Essve is already a highly trusted brand among craftsmen. By integrating Essve fastening products into Spec Toolbox, engineers and specifiers can calculate and plan with our solutions from the very start. It is a big step in making Essve the obvious choice from design all the way to installation, ensuring that the voice of the craftsman is heard throughout the process. Mass timber is still a relatively new material for many engineers, and at Essve,
Hey, and good morning, everyone. Do you hear me?
Yes, we can
Yes.
hear you.
Yes.
Okay, thank you. Welcome to our presentation or webinar, Essve Academy 13. We are proud to follow you follow us with our webinar. I think I want to leave some words to my colleague Eno from Estonia. Please, Eno, you can say some words, please.
Hope you can hear me.
Yes.
Yes, that's me, Enno Rahuoja, located in Estonia. I'm very welcome to, especially here in the Baltic Academy Day. But I wanted to say especially that Lithuania today have the restoration of the Independence Day today, and probably many of you are not participating and looking that after, but whoever is here and real present, we are happy to have you here. We hope you enjoy the session and find both insightful and useful the academy message what we're carrying on today. So here we go. DR, continue.
Yes, thank you. As you see from the title for this presentation, we are proud to present our partner, which we will have cooperation with, is Spec Toolbox. And today's webinar, we will have focus on both reinforcement for the hull and notch, other support with Essve's screw in Toolbox. Our webinar will be normally again, it will be in 3 parts. The first one is about Essve, and the part 2 I will leave the screen to my colleague Marco from Toolbox to present the program and how you can use Essve's product in the program for the reinforcement. And the third part will be if you have questions or you have feedback, is open for all. First, I will say welcome Marco to our webinar. And this will be the first webinar, and we will continue with the second in the close future, all in almost in 1 month. If we start with Essve, again, that we are in leading a fast company in the Nordic. We have proud that Essve founded from 1970. We have in almost 7 countries. We almost 200 employers, and we are part of Bergman & Beving's group. To imagine how how big Essve is, we sell almost 5,000 product screw for 1 day, and we have 4 applications, main application: foundation and structure, building, and interior finishing and outdoor Carpenter. And you, like a structure engineer, we will have focus in the first part, which is foundation and structure. And again, sorry. Yes, and again, if you want to use our program for the axial load connection or lateral load connection, you can use our Essve program, which is very easy. You can see the 3D in the same times, and it's free online. If you have questions, you can please contact my colleague Eno in Estonia. He is our technical sale, and he has more than 25 years experience. Now I will leave the screen to my colleague Marco. Please, Marco, you can
maybe
take
one
over.
moment. I will steal
Yes.
Marco from your moment. I will launch also when you do an introduction the poll. How many have heard about the toolbox? And
Yeah.
Go ahead. Say now some words. Yeah, go ahead,
Hello,
Marco.
everyone. Thank you, Dr. Thank you, Anna, for inviting us. So, hi, everyone, and good morning. I'm Marco from Spec Toolbox. I'm product manager, and I'll be taking you to the highlights and overview of the platform, and also how you can use and utilize Essve screws within the app. So, let me start sharing my screen.
Yes.
So, once again, thanks everyone for joining us, and a big thank you to Dr. Victor and Anno for inviting us to this session, and also for making this partnership possible, and have integrated Essve products into our tool. So firstly, we're going to take a closer look and talk about quickly who are we, also overview of Spec Toolbox as a platform, and then we're going to take into some short explanation about the connection design in Spec Toolbox, and then we'll go to two design examples. So first will be beam penetration design with reinforcement, and second beam notch design also with screw reinforcement using Essve screws. So firstly, also to mention, you can all jump to the platform. It's a web-based. You have the link below you can use. The majority of the platform and app is free, also especially using Essve products. But if you want to try all the features and functionalities and collaboration, you can have an access for 60 days if you reach out directly to us or with the Essve team. So also feel free to do that in the back, and we'll send also some information after the session. And in terms of just an overview, as I mentioned already, all the Essve products and applications using Essve products are free on the platform. But if you want to try some of the differences in terms of manual inputs, build-ups, enterprise and management, so shared projects and create and save custom build-ups, that's something that you can test it with this pro trial. In terms of the overview of the platform, so firstly, we'll take brief information about who we are. So we are a team of 55 people, both software developers and structural engineers. We are Spec Toolbox started in Australia, where our founder started this idea more than 3 years ago, as he was one of the managers from the big CLT producers over there. So the idea is to scale it out from Australia to New Zealand, Europe, and North America. We have teams from Australia, Indonesia, Ethiopia, and Serbia. So we are scaling our team across the globe. We build software for designing of mass timber and connection products, and our mission in general is to make innovation products easy to specify. In terms of how we help engineers, so quickly, this is here are our main values. So in terms of ecosystem, you can access the whole infrastructure and use different product materials and suppliers instantly. in terms of the calculations, we like to say that we are a white box, so all calculations and formulas are transparent. There's also a big advantage of flexibility. So you can work with different design codes, standards, and also analytical methods. And in terms of the maintenance, we provide all the maintenance and we keep up to date together with our partners, so you can be sure that you're using the latest references and latest products in the app for the design. Also, quickly before we jump to the app, a quick overview of our development. So as from recent, we have integrated Essve products into the platform, but we are also constantly working on the new things and new features and new integrations. So, and maybe what's interesting, in March, we'll have the new update on the fire design module, both CLT and GLT, that will be combined into one module. Also, CLT shear wall will be available, as well as the new hanger module. So also an overview of next month, but that's something that we can also mention in the second session. Quickly, I'll take you through some of the basics of the app. So if you register or log in, you'll see that you'll pretty much have the same screen and menu as I have here. So from the start, you can see what categories we have in here. So you can also filter out these by clicking on these categories. So both CLT, glue lamp, screws, LVL, light frame, brackets, composites, and dowel and bolts are available here. Also different regions, depending, of course, on which you register. So Europe will be default, but for Pro users, they also have option for switching this accordingly. And in terms of the different applications, we have both, we're covering both member and connection design, and also some of the basics as for CLT floors, shear walls, diaphragms, but also timber beams, columns, and some advanced application as beam penetration, rib deck, timber concrete composites, then connection, screw design, dowel bolts, and also specific application and connection details are also available here below. And I'll just show you how you can quickly find which calculators are covering mainly Essve screws. So here on this menu, you can switch between different suppliers. Let's say if you go directly on Essve, you'll see exactly where some of these products are available. So you can see plenty of application and modules around here. And if we click on any of these, you will have an option for creating new projects or adding calculation to an existing one. We can create quickly one of the examples, so Project Essve, and I'll take you through screw module, so you can get a feel of how these calculations work. We'll go, of course, cover in a minute specific connection details and design of reinforcement, but just for example, an overview where you have option for, as I mentioned, toolbar with different regions, or information about metrics, option for saving and printing, also and different configuration for different materials. So we also have integrated CLT and CLT suppliers into design. So here, for instance, if we select CLT, we have different loading options as well. We have option where we can configure thicknesses, densities.
Yes. Please, if I disturb you, if you go up again to the figure here, this connection, which type of connection is represented? It's almost like if we say this is clear shear, or it can be a combination between shear and axial load. This is typical connection for shear connection, clear shear connection between two beams, by example.
Yes, that's right. And the point of this module is where you can configure practically any, almost any type of connection. So that's the flexibility also for vertical, but also inclined screws. And just to wrap up, so you have also different materials and products available here. So you can take the properties of these timber suppliers instantly with using Essve products and properties that are listed here. So all the screw families and screw types are connected with this are available. We have some filtering option in this module where you're going to only if this is on, you'll see only compatible screws in terms of the length and diameter for this configuration. So
which please, with that you mean, by example, if you have this connection, you can just choose the screw which can be fitting to this special application. You cannot choose like other type of screw which not fitting to this application.
That's correct. So you
Yeah.
have information about member types, so either steel to timber or timber to timber, and then filter out by partially threaded or fully threaded, depending on what is being selected. And the latest last filtering is regarding the compatibility of the length and diameter. So yeah, we have multiple layers of that in the app. Going further, so I'll quickly go back to our design examples and some of the information about how the design is performed in Spec Toolbox. So firstly, about the connections. So really quickly, but why connections are important. So crucial to think of connections from very start of the design, even in the preliminary phase. We're trying to determine the element dimension. It's very important to keep in mind that which connections will be used between the elements. And because of that, we as engineers and designers need to have a fast and reliable solution to verify what's possible and to see what's not possible. And that's something that Spec Toolbox can help a lot. In terms of the screw connection in general, we are using screws to provide optimal performance in wood to wood and steel to wood applications, and screws with unique thread design and coating, resistance to withdrawal, and with durability in various wood types and environmental conditions can be our solution in most of our the connection design. In terms of the properties of screws, so we have the screws with different applications. So I'm sorry if someone is not muted. That would be great to.
I'm working on to find who is not muted. Just continue.
That's okay.
Yeah.
That's fine. Thanks. Yeah, in terms of the screw properties, so we have many types of screw heads, and depending on the purpose that they need to be applied to, there can be countersunk, cylindrical heads, washer heads, or hexagonal. Washer heads have higher head diameter and preferable for clamping two members together, while cylindrical heads have a smaller head diameter and preferable, for example, for screws to be drilled below the surface of the timber member. Similar to that, we also have the application screws depending on the threaded part, so they can be fully or partially threaded. For instance, we use fully threaded to utilize the high withdrawal capacity because of the longer thread lengths, and they can be used for reinforcement purposes, which will be showing in our examples in the next slides. On the other hand, we have partially threaded screws that are mostly using for clamping two members together, and they're used for post and beam applications widely. In terms of our design examples, so we're going to take you through specific modules. We have here some information about our structural system. We're going to use as an example for the connection design. So here we have pre-designed our CLT floors, beams, columns for a post and beam mass timber structure. What is important, we're going to use the information about GLT beams, so 320 times 720 GL24 28C. And our first example will be basically directly on beam penetration design. So we have our member dimensions. So we have tributary loads and calculated total load that is acting on this beam, and we'll have request of the penetration. So we have two rectangular penetrations at 1.8 and 6.2 meters, and one circular one at 3.2 meters. So let's get to the app, and I'll open this example that I prepared already, but we'll take through each step and also result part, so you can see how this is working. In terms of the start of the input, so we have here a pre-selected GLT, and from the supplier perspective, manual input is on, but we can also use some of the supplier from the timber applications as well. In terms of the cross section, so as I mentioned, 320 times 720 is being used with 8 meters span. So quite substantial span, and we also have some of the big openings. So this is something we're trying to manage without, and then with reinforcement, since without reinforcement, we'll see that this is not working. In this section, we can select up to 5 different penetrations in this design, and for each penetration, we can select, is it a rectangular or circular one, which is practically the dimensions of these openings and what are the locations. So you can see it's 1.8, 3.2, and 6.2, and we put it on the middle of the beam, but you have also option for configure this in the wide dimension as well. In terms of reinforcement, so it's a bit of iterative process. So I also pre-selected that we're not going to use reinforcement, so we can see in the end what's happening. Our complete design method is based on the new Eurocode and just this information. And in terms of the loading data, we have here input for total factorized line load. Nevertheless, if you look at the other calculations, you see that we already have national annexes integrated, and this is something also that we are working on improving. So in the next period, we'll also have improvement on the optionalities in this calculation as well. The last part here is purely on some of the properties and coefficients that we can configure here. So you can see from service classes to some of the coefficients to load durations. In terms of the design and what is happening in the back, you can always see what are the preview of the output. So we can see here what is happening with geometric limitation, tension verification for unreinforced penetration, flexure verification, and shear verification. And we can clearly see that this design is not working without using any screws. So we have also option to see this in detail in all the tabs that we have here. But before we're going to do that, let's try to add reinforcement and see how we can make this design working. So I'm going to try and click here for our reinforcement to use the actual reinforcement. And within that, we'll see that we have a new tab here popped out. So in this tab, we can choose exact screw supplier. So Essve is pre-selected. Within that, we have option for selecting other or the complete list of their screw families. And also within all the design, you'll see that we have these green eyes next to inputs. And once clicking one of these, you'll see that we have a drop-down menu with educational content. In this case, when you click on the screw families, you'll see the complete list of Essve products, and also with what is being selected is on green color. So you can have an overview of what are the alternatives, and maybe if there's some specification that you didn't know in terms of the when selecting the screws, so you can have more insight of what actually is being selected and used in the calculation. Once the screw family is selected, you have an option for applying and selecting any of the appropriate diameters and length. So for instance, if we use some lower length, you'll see how this is updated both in dynamic images, but also in terms of the results. The only thing with the shorter screws that is reinforcement design is not working. So the tension is too high for the length of the screw. So we will use the bigger length, so we can be sure this is something that is working. In terms of the results, we see that on overview we have everything in green, and the reinforcement is actually working. But we want to figure it out and know this how all the steps of the design is working. So because of that, we provide all the transparent calculation in these tabs. So starting from the panel properties, you have information about the grade that is being used, and also all the geometric properties and section that is about the section that is being used. Next tab covering the action forces, so you can see based on the load that we applied, what are the forces in the location of each penetration, also bending moments. Going further, we have next tab covering only geometric limitations. So here, basically, depending on the standard, we have all the information about what are the requirements, and also are the distances between the edge and between penetrations fulfilled. Then we have information about the flexure design, shear. So this is purely on the cross section. And then we have reinforcement geometry. So in this case, our position of screws and reinforcement in the right place. The last part is on reinforcement design. So the idea is that on the reduced cross sections, on the places where we have penetration, the tension perpendicular to grain is being transferred to or with fully threaded screws that we set up from Essve. And you can see here the whole algorithm and procedure of how that process is being done. So all the formulas and calculations are linking here, so you can see what are how we calculate the forces at the first step, and in the end how that forces is being transferred to the screws, or how if the screws has enough capacity of transferring these. So it's a separate procedure for rectangular and circular penetrations, but we can see how practically verification of these screws are being utilized. You can see characteristic axial capacities of the screws, and in the end, you can see the design capacity of the screw. So practically, what is the utilization based on all the based on for each penetration. So you can see here that for the first and the last penetration, we have utilization at 98% for the screws, but for the second or for the circular penetration, it's on 54. So I'll leave this design example at this stage. I'll also quickly mention that we also have option for detailed and summary report in this stage, and I can quickly show you how the summary report looks like. So in the end of the design, we have option where we can save this and generate a PDF report that will be just a summary of the results, or a detailed report where all the calculations will be shown up. So this is the preview of the shorter version, where you can see all the examples and information about this. Going quickly, I'm going to quickly take you through one more example of how you can utilize Essve fully threaded screws. So in this case, we have a beam notch design example where there's a situation where because of the architectural requirements or because of the fire, we need to notch the bottom of the beam that is supported. In this case, it's connected with custom steel bracket and fully threaded screws. In this case, we have information about what is the maximum factorized reaction force. We have information about the notch dimension, and we're going to use the Essve screws for the reinforcement. Going back, so I'm also opening again one of the examples I prepared here. So we have the dimension of this beam, again 320 and 680 millimeters. We have some information about supporting column or the notch part at the end, and also for the total notch. So we used 140 millimeters, or we have 540 remaining. And for the parts that of design, it's used the current Eurocode. We have factorized the design force in 180 kilonewtons, and we have information about service classes, load durations, gamma, and cases. And we can see that this check without reinforcement is not working. So we can just add reinforcement, where we have additional inputs for the screw data and screw geometry. In this case, we pre-selected again fully threaded screws from Essve, and we have option for selecting different diameters and lengths. In this case, we also have option for configuring the angle of reinforcement, also the position of and number of screws that can be applied. And also we have the option where we can embed the screws as well. So in this case, we used 15 millimeters, but we can also check that and modify it based on our preference and design. The last part on the checks and the results, we can see what's happening without, but also with reinforcement. So we have information about shear check, notch area reinforcement design. So are we using the right screws, and what is the utilization, and what is geometry check for these screws? In these tabs, all these results and information is listed. So both for geometry, shear check, material properties, and reinforcement design. So again, how the utilization works, and are we using the right screws? So we try to provide all the information about the references as we go, and also information about the numbering, how it is, what are the intermediate results, and how you get the utilization number. So in the end, again, you have information or ability for accessing the PDF report, and that is basically this. So you have the option where you can go through all the details of reports, see information that is being used in calculation, and references together with it. So this is an example of the detailed report we used in this example. So I'll leave some room for questions and any comments or feedback from you. Again, thanks everyone.
Thank you, Marco, for a great presentation. We can. This is what Marcus have going through. If you have some question, please you can lift up your hand, or you can write in the message beside. And just to now, I will say that our next webinar. We will continue with Space Toolbox demo tour, and we will coming back with a subject which type of connection we will focus on it. If now we have one question from Eno, please, Eno.
Yeah, I see in a chat field there is Ilimar who have asked that Marco, is there a plan also to create a modular for calculating timber frame shear walls with slab cover, like OSB or something like that?
Yeah, so light frame shear walls is on our roadmap, and that should be available in the next couple of months. So we will let you know as soon as that is in the app. Currently, we have regular timber frame, so just a gravity load calculator, but light frame shear walls is also something we're working on at the moment. So are expanding our availability of calculators, not just CLT, but also to other parts of regular timber design.
Yes, thank you.
That's good news.
Yeah, you can lift, and I can say if you have some question about Space Toolbox with SVS product, you can just contacting me or my colleague Eno in Estonia. Otherwise, you can contact me direct Marco if it's okay for you, Marco.
Of course.
Then for the East, you have my colleague Radik in Poland and Eno, like a technical sales engineer. I won't just remember that if you want to use Essve, you just scan this QR code, but I think you now good about Essve. I just want to lift up the rise up the next poll questions about what how you writing this presentation for today. Yes, can you lift up?
Yeah, I will pick up that poll now, and for everyone that feel free to test it. The Spec Toolbox platform and next Academy is in April 8th. So it's time to raise maybe in April 8th also more questions if you have found some trouble. We try to leave more time for feedback area. So thank you very much.
Thank you. And I know that was too many information in the short time, but hopefully when you're starting to use both the Space Toolbox, and you will get more questions, and you get like something you not is not classic, so you can feel just free to contact me or Eno or directly with Marco. Yes, thank you for joining us today, and hopefully we see the next time in the 8th of April. Thank you.
Thank you, everyone.
Thank you.
Thank
Bye-bye.
you.